We have Darko from AWS with us. Darko?
Hello, I think you should be able to see me now. Hello!
Absolutely. Hello, how are you?
Very good, very good. On my fourth coffee of the day, so it's all good.
That's excellent. So Darko, you're now based in Germany, right?
Yes, I am. I am based in Berlin, Germany, lovely Berlin, Germany.
But you were born or used to live at some point in Serbia, right?
Yes, I was born in Serbia. I originally come from Serbia, from a lovely town up north called Subotica, so on the Hungarian border. I basically left Serbia roughly 10 years ago, almost now. And yeah, moved around a bit. I used to live 2 years in Czech Republic, lived 2 years in Malta, lived 2.5 years in Ireland, and now I'm in Germany. So had a big Euro trip in the past couple of years. So
yeah,
I'm done
excellent.
traveling.
Getting back to Serbia, I've been there several times and I really enjoyed the atmosphere in that country.
It's great.
Belgrade is a beautiful city.
Belgrade is.
The first time I've been there, I participated in a conference called Synergia.
Aha, Synergia, yes, aha. The Microsoft conference, yeah.
Exactly. I wanted to check if you know the conference.
I know. My first conference ever. So 2009, I think, or 2009, my first conference, Synergia, was, it was the big conference back in those days in Serbia. It was like a paid event, and back in those days, that was like a ridiculous amount of money. It was 150 euros for 3 days, and
Yeah.
you know, a lot of money for that time. So, but I do remember that quite vividly. Yeah.
Then more recently, I visited Belgrade for IT Connect,
Okay.
another conference.
Yeah. There's a lot of things. There's a lot of things happening now in Belgrade, and you can see that the IT community is growing in Serbia in general. So, and even from the AWS perspective, we have 4 AWS heroes coming from Serbia. So it's not my fault. It's because we have a lot of great technical people in the entire region. So you can see that the actual crowd and the audience and the capabilities of the local region are growing exponentially with the amount of conferences happening, from traditional Microsoft-based conferences to something coming from AWS to even things like a JavaScript conferences or like, I believe, like AI and machine learning based conferences. So a lot of things happening in Belgrade.
It's growing, it's growing. Yeah. Yesterday we had a session on infrastructure as a service, and now you're proposing infrastructure is service on Amazon, right?
Is code. Infrastructure is code.
Is code, is code.
Is code.
Yeah. Okay, you've got the floor then.
Thank you very much. Yeah, let me try to, how can I share things? I can do this. This
is the green button.
No, yes, this, and this is why I like Zoom, because I can share this. I'm sharing something else. I don't want to share that. I want to go back a bit, like that. Cool. You are able to see my screen right now. Is that correct?
Right.
Perfect, because I'm streaming from a laptop. I'm streaming from a desktop, and the presentation is coming from a laptop via USB capture. Fun times.
You DevOps guys.
We like to complicate things. So
good luck.
Thank you, sir. Thank you, Florian. Hello and welcome to talk about infrastructure is code. People usually say infrastructure as code, which is true, but actually in 2020, infrastructure is code, right? Everything you do on the cloud, no matter which cloud you're doing it through some piece of code. Even if you like clicking on things, that's still making an API call somewhere there. And, you should more likely approach it through the proper uses of code. So this talk is going to basically cover around a couple of services that are available on AWS and a couple of best practices to help you develop your infrastructure as code or is code on AWS. So if you are using containers, if you're deploying servers, even if you're deploying clusters of servers, you should definitely do it through code. No question about it. If you're going to deploy a single container, a single server on AWS, you should do it through infrastructure as code. So a boring agenda slide, but this is something we're going to be covering today, I guess. But that doesn't matter. I'm going to try to make the rest of the presentation a bit more interesting than this boring slide. So what is infrastructure as code? Well, back in the days when I started my IT career, and that was like 15 years ago, 14 years ago, quite a bunch. I'm relatively young. So, you know, when we used to provision infrastructure, it was something like this, right? There was a bunch of servers, bunch of, well, desktop PCs acting as servers in this case. There was a bunch of things we needed to put on a shelf, rack and stack, plug in a bunch of cables, install the operating system and all of that, right? And, you know, even not so long ago, a company I used to work for, my title was Server Provisioning Administrator. So my job was basically to install operating systems on servers. And this was a very manual task. So you take your server, you take your favorite Java-based remote administration application, mount an ISO and install it, and then rinse and repeat 500 times. How long does it take me to install 500 times Red Hat 4 on a bunch of servers in Alaska? Exactly. So things have changed since the yonder time of plugging and cabling and, you know, at least having some physical activity when it comes to provisioning. The things look different now. The things look like this. Yeah, I'm a fan of this. I like looking at code. So provisioning and deploying infrastructure is actually done like this. No matter how you do it, it's done like that. So instead of racking and stacking, you do a lot more typing, pasting, coding, and linting, yeah? Which still has its problems, but I would take this over any Java-based remote administration application any time of the day. So the goal of the infrastructure as code is basically to define your infrastructure as code, right? And provision it. The benefits of this actually makes your infrastructure changes repeatable and predictable. So by scripting, you're not even scripting, you're just describing how you wish your infrastructure to look. It's super easy to replicate it and actually understand what's going to happen. On top of that, you can release infrastructure changes with the same tooling, with the same pipelines, with the same CI/CD setup you have for your application delivery. And if you have ever had to replicate production into development or staging, yeah, you know how that big of a problem is. So replicating environments is super easy when you have them defined as code because it's potentially just a change of parameters and it works fine. Now, just to kind of clear things up, two types of infrastructure as code, right? There is the imperative one where I tell you what to do. Hey, launch me an instance, create me an S3 bucket, launch that database, and here's the command how you should do it, which is fine. That's still, you can script things in Bash or Batch or Python or PowerShell, whatever. But also, there's a better way. You can declare things or having a declarative approach. So instead of telling you, hey, create me an instance, tell it, hey, I need an instance. And I want my instance to be configured like this. Then what the framework does is takes your desires and your wishes and actually does a whole bunch of magic. You don't really care how does it do it, but it actually creates this instance and everything else for you, right? So that's very important. Now, with that out of the way, you may be asking yourself, who is this bald person and why is he talking at me? Why is he screaming at the camera? Well, good thing you asked. I was introduced by Florin before, but my name is Darko Meszaros. I'm a developer advocate at AWS. I've been working for AWS for almost 5 years now. I originally do come from Serbia, and you can see my lovely migration path. That's my personal migration between multiple country vendors. And currently, I'm vendor locked into Germany, and I started off in premium support way back 4 years ago in Dublin, and moved on to solution architecture. So I work with a lot of customers, and now I'm a developer advocate, and my job is basically to talk to you, our developers, the folks who use AWS, and get your input, get your feedback on the way we do things. How can we make things better? And at the same time, maybe educate and entertain, right? So this is why I do these things. Also, if you want to hear more things from me and you wish this 45 minutes was longer, you can check me out on the social medias and the Twitches and the YouTubes and whatnots. I do a lot of streaming and a lot of content. So actually, even today at 6 p.m. Central European time, I'm doing something. So do join me on all of those things. And yeah, I hope to see you all there. Okay, enough talk about me. Oh, I have the same shirt. Oh, almost the same shirt on the photo. As you can see, I have 5 shirts. So let's talk about the big boy in the room, or the first thing when we talk about infrastructure as code on AWS. AWS CloudFormation. Now, what is CloudFormation? CloudFormation is an ISC, or infrastructure as code framework, that allows you to, this is the bad presentation. This is the one that skips ahead by itself. Wait a second, can I pause this one? All right, I'll try to keep it here. So CloudFormation, it's a language framework that allows you to write things in YAML, something like this, and you can provision your infrastructure code through YAML or, God forbid, JSON, right? You define these things called templates, which are written in either YAML or JSON. In those templates, you define things such as resources. Those resources are your actual AWS resources. So things such as S3 buckets, EC2 instances, RDS, and basically anything that's supported on AWS. And once you define those things and you give that template off to AWS, CloudFormation creates this thing called a stack, right? And the stack contains multiple resources, right? One or more resources. And the way you define those resources, again, it's just a simple case of, hey, I want this resource and I want this to be its parameters. End of story. Let CloudFormation handle the rest, right? The template itself, this is kind of the anatomy of a template. You have resources, parameters, conditions, outputs. So basically, there's a lot of elements you can add to a template to kind of make your template that much better, right? So, you know, from doing important things like parameters are very important, and people tend to skip over them from time to time. Parameters give you the ability to define variables or define changes as you launch your stack so that you can change them on the go, right? You make your templates basically agnostic. You can reuse them. Hey, we talked about deploying testing and development environments, right? Well, you can do it simple with a single template, just change the parameters. There we go. And one of the things that CloudFormation is not just a place you write YAML and JSON, but because it's code, you can also test the code, right? There's a lot of different things that you can use, a lot of different services and features that you can kind of apply to CloudFormation to stick CloudFormation in your CI/CD pipeline, and do things like do static tests with linting, such as the lovely CloudFormation linter and CFN-NAG, lovely tools to do static testing of your CloudFormation code. And then move on to like something else, for example, like TaskCat is a tool that actually deploys your stacks across multiple regions with specific sets of parameters. And then based on those parameters, it launches them. And if they're successfully launched, it continues with, yes, the launch has been successful, and terminates that stack. So a bunch of different tools. And as I said, it's great to write these things on your laptop, and it's great to have them there, but they belong all in the pipeline. So there's many tools, many things, many integrations, especially on AWS, when you run CloudFormation in a pipeline on AWS. So for example, the AWS Code Pipeline Service, which is our, well, you guessed it, pipeline service, actually has great integration with CloudFormation. So this is where CloudFormation should be in. But you may say, Darko, that's all fine. But hey, you know what? I have my cluster back home. This cluster provisions unicorns. I want to provision unicorns with CloudFormation. CloudFormation is not good for me. Wait right there. So there's a relatively recent feature available. It's called the CloudFormation Registry. The registry basically gives you the ability to create completely custom resources on CloudFormation. So it requires some coding knowledge. So you have to be a bit of a developer to develop your resources in Python, Java, or Golang as of now. So in essence, what happens here, you create custom resources that exist within your account, and you can basically invoke them in the same way you would invoke a resource like an EC2 instance or an S3 bucket or anything else through CloudFormation. So CloudFormation Registry is basically doing that. There's a lot more effort to do that, but a common use cases, and this comes from our AWS partners, such as like, Datadog, New Relic, Spotinst, they already have these custom resources available to you that you can provide them. So if you want to, for example, deploy an Ops Genie user or a Datadog dashboard, you can do it through CloudFormation now through CloudFormation custom resources. And if you want to check more on CloudFormation registry, there's a bunch of GitHub repositories available there, and there's even a nice walkthrough on the documentation itself. All right, moving on to SAM. I think this is the part of my presentation where it's going to freak out. It's going to move on left and right. So I'm going to try to keep, without having to stop the presentation, I'm going to try to keep jumping back and forth because I didn't look at my presentation timings. So SAM. So what is SAM? SAM is CloudFormation's little younger brother. So SAM, or Serverless Application Model, is basically a transformation for, see, it jumps here. Oh, there we go. Come and go back. There we go. Nope, I am sorry. I'm going to have to keep it on here. I'll explain. So SAM is, let me go like that. SAM is, CloudFormation is younger brother. Basically, it's a transformation for CloudFormation that enables it to basically create serverless resources with much more ease, right? So it has a lot of quality of life improvements for creating serverless applications. So actually, I think I have time. So give me a second. Let's do one thing here. Select all, all like that. And use timings. I don't care about timings. Thank you. Like that. Will this work? Try. It works. Perfect. So basically, it gives you the ability to create serverless applications or serverless applications with much more ease. And how does that look like? Like this. So this is just 20 lines of code that enable you to create a Lambda function, an IAM role, and an API gateway for your serverless applications, and not even to mention a DynamoDB table at the last 2 lines. So it's, in essence, CloudFormation. It supports anything that CloudFormation does, but with the SAM template or SAM transformation, it gives you the ability to write your SAM serverless applications with much more ease. Think of it as the good friend of the serverless framework. It does basically the same things. It's a purpose-built or a purpose-modified framework for serverless applications. So if you're writing serverless and you wish to use CloudFormation, please use SAM. It's much, much easier to use SAM than it is to use CloudFormation for serverless applications. But SAM is not just a template. SAM has also a bunch of other things. SAM has a lovely CLI. As any good tool out there, it must have a CLI. So SAM CLI gives you the ability to test your, actually build, test, and deploy your serverless applications from the command line. It also gives you the additional ability to do a bunch of debugging inside of an IDE or even on the command line. So it's, of course, lovely open source, and there's a bunch of things you can actually do with SAM here. So I would say if you're using SAM, you can use SAM without SAM CLI, absolutely, but you shouldn't, right? SAM CLI helps you a lot on a lot of things here. Okay, so SAM CLI. Here's a great example how SAM CLI should be used. You install it, of course, with pip or with brew in the recent versions. You can install it with homebrew. You initialize the application, basically creates the entire directory structure for your application in this case. Then you can do a bunch of things. Now, this is where the big part of SAM comes in, the SAM local. Or if you ever created a serverless application on AWS, one of the things that you might find stressful is the ability to debug, test, and basically try to figure out why your serverless application is not working. It usually would involve a lot of deploying to the cloud and like, okay, looking at the logs, okay, let me try to deploy again, whole lot of things. Now with SAM local, you can actually execute your Lambda functions locally, right, on your laptop. So if you're sitting on an airplane, you can technically execute Lambda functions and API gateways locally and do all those testing, right? So you cannot emulate a DynamoDB table, I believe. That's not possible yet, but API gateways and Lambda functions are perfectly fine. So you can basically deploy a big chunk of your serverless application or SAM application locally. But because of all the other features from SAM, like the building, the deploying, and the packaging, you can actually fit these bunch of commands into a pipeline. So with Code Pipeline or even Jenkins, which has the SAM CLI plugin, these things, again, belong within the pipeline. And if you deploy your serverless applications, you would most likely keep these things at the build or the deploy stage. And last but not least, there's a couple of commands I want to mention. The SAM logs commands. If you ever wanted to stream a log or logs from your serverless application to your laptop, you can do that. Basically, you can point it to a function and the logs will be streamed locally. So that's really, really cool. And if you're a fan or user of the AWS serverless application repository, you can easily publish to the SAR by using SAM publish, right? There we go. Now, did you just say local tests? I would like to see that, right? Well, actually, I have a lovely prepared recording here of me doing this thing. So let's have a look at SAM test. So SAM test, I need to hit play. Yes, there we go. So I actually have a simple SAM application here. Just a hello world application, doesn't do anything special. This is the template that basically creates a single function. There's no API gateways, there's nothing else here. Just a single Node.js serverless application. And if we look at the actual, the Lambda function here, it's just a hello and a name, right? I pass it a name and says hello, whatever your name is, right? So let's see how can we actually test this Lambda function without pushing to the cloud. I just created an event. An event is just a JSON file, a payload that I pass it on to my Lambda function. In this case, I'm passing the name, right? So I'm running SAM local invoke, passing the event and actually passing the Lambda function name. So what it's going to do here is going to pull a container, basically runs Docker locally, and you can see there, hello, Alan Ford. It basically runs this Lambda function locally on my workstation and output. So that's about it. Super simple. Now, the only thing that would prevent you from doing this on an airplane, if you're doing it for the first time, is it may be missing the Docker, what is it called? The layers for the Lambda function. But if you have that already, it should work like a charm. So perfectly awesome thing. So if you're a fan of serverless, if you like CloudFormation and you wish to do local testing of serverless applications, AWS SAM is the thing for you. Okay, moving on to CloudFormation's uncle, buddy, somebody else, I don't know, CDK or Cloud Development Kit. Now this has proven to be my favorite framework of them all. AWS Cloud Development Kit is basically a framework for deploying, again, infrastructure as code. And why would you use this? Well, maybe, JSON is not your thing. You're not a robot and reading JSON is hard. Or maybe YAML, ain't your thing. You can't stand the tab spacings as a lot of people can. So maybe you heard about this fangled thing called Python, and Python does a lot of things. Maybe you're just so good at Python that you can maybe fly with Python. So why not use the knowledge that you already have in a specific language and apply it to infrastructure as code? Why do I have to go and do some JSON and YAML and, do some weird domain-specific language things when I already know Python, or maybe I know JavaScript, or maybe I know TypeScript, or Java, or C# or Golang coming soon? So basically, CDK can help you shorten that development cycle with the ability to actually develop your infrastructure as code through any of these languages, right? So it's much more approachable to people who have never done this before, but as a lot of us sysadmins, operations folks, even developers have experienced with at least some of these languages here. So, also F# is supported, but it's not here for some reason. So you can use the existing tools and workflows, so you can stick CDK inside of your existing pipelines, and you can test CDK with existing tooling, and I'll actually get to that. And it's just a really great way to build components, build things, build services, and kind of being able to reuse them. And like my biggest thing on CDK is you can read things off disk. You can create a VPC with a single line, right? So a lot of heavy lifting has gone off from you, right? So kind of to explain what is part of CDK, because CDK is just not a language. CDK is the CLI, let's call it that way. CDK is just a CLI and a bunch of API constructs, right? And a module from Node. So what do you do in CDK? You create this thing called apps, and apps contain multiple stacks, and stacks can contain multiple resources. So it's this lovely Christmas tree hierarchy here, right? So you create these things and you write these things in one of those languages that I mentioned before. Then the CLI is actually the main thing here. The CLI takes that JavaScript or Python code and converts it to CloudFormation. So it does all of that for you, and it actually hands that over to CloudFormation, because you should not be concerned, or CDK should not be concerned with deploying those things. CDK should give it off to a service that's well-versed in doing those things, so it's not repeating anything. So it's basically giving off that stack to CloudFormation and let CloudFormation manage it. But still, it's much easier to write this than to write in CloudFormation. And speaking of writing things in CDK, there's 3 types of things you can write: CloudFormation constructs, services, and design patterns. So CloudFormation constructs are basically the simple way to define resources, any way you would do it in CloudFormation. Services are, let's say, more opinionated way to do things, or services with sensible defaults. And this is like if you create a VPC in CDK, it will create a VPC and 4 subnets and a bunch of other things. And also there are design patterns. Design patterns are very powerful. So let's say you need a Fargate, ECS container-based Fargate application that's running behind the load balancer. You can go ahead and build up all those things manually, or you can do it in these 4-5 lines of code. These 5 lines of code in CDK will actually create 817 lines of CloudFormation code, whole bunch of services, and it will create a Fargate service, basically a container-based application running on Amazon Fargate, AWS Fargate, behind Amazon ECS. So simple as that, very powerful, right? So it gives you the ability to kind of focus on your application, not try to focus too much on infrastructure, right? Abstracts a lot of things from you. Now, as this has a lot of generic code patterns and properties, you can also do things such as testing, right? You can do a bunch of different types of testing on CDK. And one of the things you can do it, especially when it comes to like JavaScript, you can test your CDK JavaScript code with tools such as Jest, right? Or Java, basically JavaScript testing framework. You can do snapshot tests, fine-grained assertions, and even validation tests. So you can actually have a proper test-driven development cycle in CDK by using these things. For example, you would create a fine-grained assertion test on CDK, like defining, hey, I expect that my stack has this instance or instance that is configured this way, and then you write your code, and then if your test fails, you have some bad code. So you can apply the same practices to software delivery as you can do. You can apply the same practices you do to software delivery to actually infrastructure delivery with CDK. Now, I'm actually going to try to do a demo here. So I want to do a very, how do you call it? A very a very raw demo. So actually, let me open up my terminal and move it through here, like so. I'm going to create a CDK application from scratch, right? So I do have some time, so I would be able to do that. So actually, let's go to workspaces, TMP. I hope this is large enough for everybody to see on stream. Let's create a directory here called mkdir. Let's do CDK Py demo. I don't think I have this one. Perfect. CDK Py demo. I'm doing this completely unprepared, by the way. So if it fails, it fails. So to create an application, to create a CDK application, you would do CDK init. Okay, actually, nvm use, and I need to have node version manager. CDK is installed using npm, so that's the thing you have to have installed. So CDK init, I can do a sample application like this. If I do CDK init sample and language equals Python, it will create a sample application, and a sample application contains a bunch of things with a language Python. So if I hit this button here, it takes a moment for this to create. It creates the entire scaffolding, everything you need to run your application. So if I clear this, and I'll show you here, there's a bunch of files here, but there's 2 files we need to be concerned about. The app.py. So if I open up app.py, you can see here that it's basically a simple application that says, hey, initialize my application and create a stack. That's it, right? It's creating a stack called CDK Py demo, and it's creating it in US West 2. Okay, so if I open up the other file, which is contained in the basically CDK demo directory, and it's called the CDK demo _ stack file. And if I would open it, stack, yes, please. So this is where I actually define my stack. Now, because this is a sample application, it actually does this for me. There's a bunch of things like it's creating a SQS queue and an SNS notification topic. So in these, 4 lines of code, it creates a SQS queue for us. And for topic, it creates basically a topic like this, right? So let's say I want to deploy this. We save this. Actually, I need to source because I need to enter the virtual environment. Pip install. There's a bunch of requirements I need to do here. Pip install requirements. Again, installing the CDK modules or pip modules for AWS CDK, so I can do all of these things successfully, hopefully. And if I do CDK deploy, it will generate a CloudFormation template for me. I can also tell it to generate it for myself, and I can deploy it manually, but I can also deploy it directly from CDK. It also tells me, hey, Darko, you're actually making some IAM or identity and access management changes. Are you sure you want to do this? I am absolutely sure I want to do this. So it's now going to go ahead and create a CloudFormation change set and actually deploy these things through AWS CloudFormation. So let me actually try to log into, maybe I can show this to you if I'm currently logged into my AWS console, and I am. So while this is being created, if I go to CloudFormation and click here, and not in Ireland, actually go to US West 2, because that's where we're launching this thing. You can see that it's already completed this launching, and we can see CDK Py demo, and we see that it has created all these things. Again, I have not told CloudFormation, hey, create this. CDK did it. And actually, this is the large template it generated for us, right? It creates this entire CloudFormation template for these 3 resources. Now, if I want to do something more, if I want to install, for example, if I want to do a VPC, so I could do pip install AWS CDK.aws. I think this is the way you can do it. Yes, that's how you install a module. Perfect. And again, if I do vim and then find my stack like so, and import a module AWS EC2 as EC2 like so. And let's create a VPC, because a VPC is the thing for me that sounds amazing when you create it. So VPC equals EC2 EC2 dot VPC, and then self, define the basic scope, and give it a name. I'm going to call it my VPC, of course, like that. And then I can do CIDR equals, and then I'll just do it 10.0.0.0/16 and close this off. I have basically defined a VPC now. If I save this and do, again, CDK deploy, hopefully this should work. If it doesn't, we'll fix it together. Okay, seems fine. Change set is okay. Deploying, all good. And you will see actually a bunch of different resources being created right now. So it's not just creating a simple VPC. It's creating a VPC with 4 subnets, 2 public, 2 private. It's creating 2 NAT gateways and all the bells and whistles you need for a proper functioning VPC. Of course, a lot of these things can actually be modified by adding different parameters. So if I wanted to do different CIDR ranges or maybe different configurations, I can also do those things within the parameters of the VPC object. Now, while this is creating, you will actually see here that the CloudFormation stack is being updated. So we can see the same events happening here. I see it's being created, and a bunch of new resources should be in the spin. So the VPC has been created, the gateway, the subnets are being created. The longest thing that takes here to create is probably the NAT gateways, because they are actually machines or servers somewhere in the back being deployed. So it does take a while. So I'm not going to wait for this to finish. It should hopefully successfully complete, but you get the gist. It takes how many minutes for me to do this? Just, okay, a sample application is cheating a bit, but I've added new things, right? If I wanted to add a lambda function, it's the same way, basically, just a couple of lines of code. And if you're interested in more CDK, I talk about CDK a lot, right? So go to my YouTube's and Twitch channel. There's a lot of content from me just there. Okay, back to this. Whoa, good. So that's us talking about CDK, but how about additional tools and frameworks? Well, a lot of people love Terraform. Terraform is great. So I actually spent like 4 episodes actually that's almost 10 hours on stream of me trying to learn Terraform. I've never done Terraform in my life. So I decided like, hey, let me learn live on stream. And it was fun. And I like Terraform. I like its syntax. It's very easy to get into, right? But let's say you wish to use Terraform because you want to do things, manage different resources that are maybe outside of AWS, right? You can manage different cloud vendors. You can manage network switches with Terraform, right? There's a bunch of things Terraform supports. But you still want to do it in Python. How to do that? Well, actually, HashiCorp loves CDK, or Terraform loves CDK. By running this lovely command, npm install -g cdk tf CLI, the name might give it away, it's actually a Terraform module for Amazon CDK, or Cloud Development Kit, which in essence allows you to create Terraform resources, or actually, well, yeah, it's basically abstracts the creation of Terraform resources through, like in this case, JavaScript, right? So it's currently supported only for JavaScript and Python, but you can basically define things in CDK in a very similar way you would do to like AWS resources. The only thing that's different here is that the properties are slightly different and the way Terraform does things. It's currently in preview, so a lot of things are missing and we're still waiting for it. But if you are a fan of CDK and Terraform, CDK Terraform is for you. So I would highly advise you to check it out. It's so much fun. Okay, moving on to the best part of this presentation are the best practices. Now, these best practices are something I've picked up from my experience and also from a lot of people I've worked with and a lot of people who actually develop in the cloud. So I've tried to gather a lot of feedback when it comes to IAC, infrastructure as code on AWS, or in general, how to do certain things. So best practice 1 out of 5. Layer your applications. Do not create everything in a single stack. Creating all the things such as persistent storage, compute, control platforms, authentication in a single stack can be a problem. Because if you want to refactor, move, or something goes wrong, it's very difficult to troubleshoot in the long run. So separate things into different stacks, different applications even, right? Don't create a monolith out of your infrastructure, right? So try to do it in multiple stacks. And a couple of quotes, this is a lovely quote from actually my colleague. Separate critical persistent storage from everything else, right? If you have a database, if you have a bucket that you keep your data in, DynamoDB, something like that, keep it in a separate stack. You do not want to delete your persistent storage, critical persistent storage, just because you wanted to rebuild your container architecture. Don't. Move it to a separate thing. Start small, right? If this is your first time starting off in CDK, in infrastructure as code, start small. Do not try to boil the ocean. Do not try to do everything at once. Just put things one thing at a time. Even if it's a single instance, even if it's a single auto-scaling group or a container cluster, do it one at a time, right? So try to figure out how that works, and then you keep on adding things as you go along. And do not have to specify every little detail. It's fine to start out small, because if you go ahead and take your big old monolith application or your infrastructure, try to just copy it into CloudFormation or CDK, you will have a bad time. You will hate the language, you will hate the framework, and you'll stop. So take it slowly. And also, this is kind of a generic programming guide as well. It's okay to repeat yourself, right? Do not over-engineer things. Do not go ahead and spend 5 days on building a whole library or whatever, just so you don't have to type things twice, right? It's fine. And speaking of over-engineering, these things have to run for a long time. Don't let the operations folks hate you because you made things too complicated, because, hey, we're engineers. We love complicated things. These are kind of the same things, right? Do not over-engineer an entire solution in CDK, for example. Do not build a whole library just because you do not want to create an EC2 instance twice or copy-paste your code twice. It's fine to copy-paste your code. And operations, don't let operations hate you. Do not. Make it reliable, make it good, but also make it maintainable. 4 out of 5. My favorite one. Use parameters. If you use things like CloudFormation or SAM, use parameters and mappings. Make your templates agnostic as possible, right? And I'm not sure how many times I have to say this, but it's very important. Do not hard code sensitive information in your templates. No matter how sure you are that your template is sitting in this amazing secure Git repository in your local environment, sitting in your bedroom, don't. Do not hard code passwords, sensitive information, keys. Use things like parameter store, secrets manager, HashiCorp Vault. Use anything else where you can actually store those things. And with the case of CloudFormation, you can actually reference secrets manager or actually parameters directly from the CloudFormation templates. Super easy, right? And last but not least, because infrastructure is code, test, right? Put guidelines, put your expectations before you do anything. Define how your infrastructure should look in a test. Make other people look at your code. Peer reviews of your infrastructure code, right? Us administrators, engineers like to think about, hey, I'm an admin, I'm an architect. Nobody has to look at my code. I looked at it. That's good enough. But because we're treating this as any other code, do that. Get other people to look at these things, right? So, because here's the thing, automation lets you mess up at scale, right? We love to automate things. It's also great when you smash that automating button and then you destroy everything, right? I have a colleague who actually managed to take offline 1/7 of the United States internet a long time ago because he was automating things that he shouldn't have. Yeah, so Be careful when you do automating things. Okay, a couple of takeaways, and this I've hammered this in all day today, but just so you know, get into your infrastructure as code early. It helps you manage scale in the long run. And one of the common questions I get from customers like, "Hey Darko, is there a service that I can just copy my resources from one account to another?" No. There are things that can help you, but no. If you do things in IAC, if you treat your infrastructure as code, it's much more easier to copy it or basically just relaunch it in a different region or a different account or whatever. Treat infrastructure as code as any other code, because infrastructure is code. Use the proper tooling, use all the pipelines, use basically all the things that you can to treat this code as any other application code, because it is. And also, the question is, hey, use the best tools that fit your needs. Absolutely. Use the best service out there to fit your needs. And this brings me to a question. So Darko, should I use which tool should I use? Should I use tool name or tool name? Yes. The best programming language is the one you're good at. So use that one. If you're good in Python, use CDK. If you're good in YAML and JSON, just CloudFormation. If you want to do serverless, do SAM. If you want to do things in a DSL or a HCL or HashiCorp language, or you want to do things in multiple environments, multiple different types of vendors, use Terraform. Why not? There's so many things out there. As long as you're doing infrastructure as code, keep on doing it, because it's 2020. We all do microservices. We all do serverless. Most of us are in the cloud. Infrastructure is more part of your application than ever before, from things such as tables to authentication pools to S3 buckets to whatever. That infrastructure is no longer just supporting infrastructure. It's a key component of your application, and treat it as such. Treat infrastructure as code and treat it as part of your application. Thank you very much. I guess we do have some time for questions. I even 5 minutes early. Wow. Yes.
Hey, Darko. Man, you're good.
Oh, thank you. Thank you.
I'm a fan.
Thank you very much. I appreciate it.
That was amazing, actually.
I appreciate it. Thank you very much.
So Darko,
yes.
How do you approach learning? I know it's a very general question, but how do you approach learning?
Yes, learn from the best. That's my first thing. Figure out who does things that you want to do very good. Follow them on the social medias, read their blog posts, and try to leech the knowledge off of people, because in these years, it's so easy to follow people. It's so easy to see what people do, because a lot of people put what they do publicly. So try to learn from other people, because they have most likely went through your mistakes and they can share a lot of information. But also, what is very important is have a clear, keep your eye on the prize. Have a clear goal, what you wish to achieve. If you wish to learn CDK, you wish to learn CDK, and for this and that reason, and then make yourself a goal to deploy something in CDK or whatever you want, because that's what you want to do, and then just go at it, right? And speaking of people you can follow, if you want to do infrastructure as code on AWS, a lovely book by Mr. Bradley Campbell is The Definitive Guide to AWS Infrastructure Automation. This is an amazing book. It goes through CloudFormation, it goes through Terraform, it goes through CDK and SAM. So this is a great book. It has only 340 some pages, but it's worth a read. So if you want to get started with IAC on AWS, this here book.
Thanks a lot for the recommendation. Speaking of Terraform, and the story you just mentioned, not sure if I got it right. So what did you do? You learned Terraform while filming yourself?
Yes. So I have a colleague.
Tell me about this experience, because I find it really amazing.
So I have a colleague. His name is Kobus, and Kobus and I look very similar. He's also bald and big and bearded, and him and I do streams together. And I'm a CDK guy, and he's a Terraform guy, and we like to banter. Like I try to make fun of him for using Terraform, and he makes fun of me of using CDK. It's just great, and we do it live on stream, right? And I decided, like, you know what? Let me actually learn a bit of Terraform so I can stay competent when I talk to him. So instead of me just opening up a book and deciding to read a book for 10 minutes and then quit because I'm too bored, I decided to announce to the world that I'm gonna learn Terraform, and I'm gonna do it live on stream. So I go up on stream, fire up my browser, fire up my text editor, and say, you know what? Let's learn Terraform. And then I basically live on stream on like 2 hours per stream, I believe, or something like that, where I spend time on trying to learn Terraform. And actually, I have 4 videos available from that. So actually, let me show you. I have 4 videos available. And I also have like my Terraform Adventure GitHub repository where I basically explain what I did. And it's also missing some things here for the last episode, but basically explains how my path was, how to learn. And I find that one of the easy way to learn is to actually explain to people what you're learning. So I'm not an expert in Terraform by no means, but this helped me out a lot to kind of understand certain things on Terraform.
And the last question, what's next for you in terms of learning?
When it comes to infrastructure as code, because I'm a fan of that, I am still expanding my knowledge on CDK because I was never a developer, right? I was a sysadmin, I was an operations folks. So I'm learning a bit more Python and I'm learning TypeScript to do more CDK, but I also want to check some other tools out there. I want to check out things such as Pulumi, which is another third-party framework that allows you to create infrastructure as code through also generic programming languages. So I'll see. And in general, I am gonna try to expand my knowledge through code. But if you're asking me what I'm gonna learn on stream, it's Kubernetes. I have no idea how Kubernetes functions. And I know that the previous talk was a lot about Kubernetes. And like literally, I know it's containers. I know there's pods. I know there's a command line and you do things in YAML. So I haven't started that yet, but I'm going to start like a streaming series where, again, I go in completely raw, no knowledge of Kubernetes and trying to like create a Kubernetes cluster on AWS and trying to understand basically what Kubernetes is and how can I use it. Yeah.
Fortunately, Kubernetes is the rock star of the day because many of the presentations today are on Kubernetes. So if you...
I will definitely check it out.
There with us and well, okay. So Darko, it's been a really, really great talk.
Thank you, Florian.
Nice experience talking with you.
Thank you.
And until next time. So we're really looking forward to have you at Code Camp.
Yeah, hope one day in person as well when the plague goes over.
We can meet in Belgrade.
We can always meet in Belgrade, absolutely.
Yeah, absolutely. Darko, have a nice day.
Thank you, Florian. Bye.